Greetings, my name is John Windust. This is for CSC 110, the final Turtle project for prime numbers. Okay, so question one. Question one, we are tasked with finding the prime numbers in the user-defined range. The way this function works is that we are basically doing a list accumulation if the number is prime. So it's going through, it's testing, is it factorable, breaking, boom, going to the next one. When it does find one that's factorable, or sorry, not factorable, it's going to put it into this primes.append. So we have a prime list here, and at the bottom we're just saying, hey, print the length of this prime list here. So we could actually print all of the prime numbers in the range, or in this case we are just counting the amount, 231. Okay, that's question one. Question number two, we are counting the amount of twin prime numbers in the user-defined range. So our first helper function for this one's a little more complicated. Our first helper function for this is just is prime. This is just returning true or false, whether it's the thing is factorable or not, or if it's prime or not. The second helper function is twin prime. So the criteria in the if else statement is if the is prime function is true and plus two integers away is prime function is also true, meaning you have a prime function and two functions away, a prime number and two numbers away is another prime number, then the whole thing will return true. Otherwise it's false. This is still just testing one number at a time. And then twin prime count, this is testing the user-defined range and creating a list of those twin prime numbers, the first number in the twin prime numbers, and then it's just counting. It looks like we're just returning the list length for the count. So here we go for this one. There are 30 twin prime pairs in the given data set. It's kind of a cool one. Okay, question number 3. For this one, we are summing up the amount of prime numbers per row, kind of an ongoing sum. So for just the first helper function, we just have another basic is prime. We've seen that before. Now we have a prime range. Okay, so this is just doing a it's creating a prime range. Now, because we're doing a row, the integers are still just increasing by 1, so this one is still pretty simple, and it's just summing each row and printing it out in prime row sum. So it's doing the prime for each row, printing out the sum, and then it just has a counter in it basically that will show it in the printout. See, here you go. And then if you remember from the from question 1, we also had 231 primes in the given range of 57 columns and 37 rows. Now, question number 4 is basically the same thing as the previous question, except we're doing columns. This one, the integers are not just running sequentially like they were in the last one, so it's a little bit harder. We have the same is prime function. Now moving into the column, the full column, what this is doing is it is printing the column from top to bottom. You can put in any number in there in the table. That's basically a header for the column, and it will print out the rest of the numbers completing that column. And this is just making a column list. You can see it's just a list accumulator, and it's returning the list. And then we have def column primes, which is basically it's printing out each column similar to the previous problem with the row, and then it's just an ongoing count at the same time. And again, this one's just a little harder because the columns, the numbers in a column, are not just sequential integers like they are in a row. But you can see we still ended up with 231 primes, even when it's counted by column, 57 columns. The last and coolest question. The last and coolest question is the turtle drawing of the entire table. So, we're just, the way this works is we're setting up the turtle table here. We've already seen this is prime function on basically every single one. Same with the is twin prime first. Oh, okay. So, I think the best way to explain this is this is the previously we saw it testing is twin prime and whether that's right or not. For this, I have it basically testing is twin prime plus 2 and is twin prime second number minus 2 because I want to be able to calculate both because I need them both to be red in the table. We have defined square drawing. This is creating the drawing for the little box in the table and putting the number in the middle of it. Right here is the most important part of this entire thing, which is it's my if, elif, else statement. And so basically if it's a twin prime, it's going to be in red. It'll come back true. It'll be in red. If it's a twin prime first number, it'll come back red. If it's a twin prime second number, it'll come back red. If it's a prime number, it will come back just regular blue. Else, it's going to come back just regular Arial 6 black, boring. Here we have draw row, which is just going to do the rows of the above. And then we have draw multiple rows, which is going to draw multiple rows of the above. Pretty cool. But the real beef of this problem is this draw square part. And we'll just run it really quick. Boom. Very cool problem. This turtle part was definitely my favorite part. And it was fun fixing kind of the little errors that were here and there. You can see the blues, these are the primes, and you can see the reds, which are all separated by 2 per the defined function of what defined definition of what a twin prime is. And yeah, thank you so much. Let me know if you have any questions. Thank you. Bye.